Alright, this is week 1 and we're solving linear equations. We've already done a practice problem and we got x equals 6. We're going to hold off on this one for a little bit as we practice 2 easier ones first. So I'm going to go to a separate piece of paper. Please join me. And we're going to try 2 more example problems. Alright, this one looks very similar to the first one we solved. There's a variable on one side with a constant term, another number on the other side of our equation. So let's copy it down. 35 equals 6x plus 19. Draw a nice wavy line below your equal sign for the 2 sides of our wall. And then we're going to look at the busier side of the equation where x is. And we're going to think about our PEMDAS in reverse. Addition, subtraction, multiplication or division, exponents, parentheses. Which thing do we undo first? Anything added or subtracted. So on this busier side of the equation we have add 19. We're going to undo it with the thing that undoes addition, which is subtraction. So if we subtract 19, so we can get rid of the 19 and get closer to having x alone, we need to do it on the other side of our wall to keep our equation balanced like a balance scale. Do not forget to put the minus sign in front of your 19 on both sides. You should have twins on both sides, identical twins. Alright, on this side, 35 minus 19. 5 minus 9 is 6. 15 minus 9 is 6. I borrowed. 2 minus 1 is 16. You can use a calculator, but if you can do the mental math, please do. Alright, on the right side, these guys are gone. Plus 19 minus 19 makes 0. So I don't write down the 0. I'm too lazy, but I will bring down the 6x. Now, I have a mystery equation that 6 times some mystery number equals 16. Now, I don't know of anything in my head that times 6 makes 16, but I do have a calculator, and I do have a process. I know that I need to undo multiply by 6. How do I undo multiplication? Well, I undo multiplication with division. Multiply and divide are opposite operations. So, if I want to get x alone, I need to divide both sides by 6. Isn't that how intuitively you'd figure out what times 6 makes 16? Wouldn't you divide by 16? So grab a calculator. I just happen to have this one handy. And I'm going to do 16 divided by 6. And I get 2.666666 with a 7 on the end of it. Now, over here I've got x alone, and here I got 2.666 repeating. Now, for those of you that know that your fractional amounts by heart, this is really just 2 2/3. I would accept either answer, provided the circumstances, it depends upon what you're doing with the answer, which one is preferable. So again, this one's okay, this one's better. Okay, now this is especially good if you're trying to check your answer, because if I put 2.66 in my calculator and times it by 6 and add 19, I won't get exactly 35, I'll get close. But if I put 2 2/3 into my calculator, times it by 6 and add 19, I'll get exactly 35. So that's why this is really the best answer. Okay, we're going to try another problem now before we go back to your notes sheet. Go ahead and copy this one down. 4x minus 7 equals 2x plus 9. Alright, now draw a wavy sign down your equal, a wavy line down your equal sign, and notice this equation is different because there's an x term on both sides of the equation. An x term on both sides of the equation. But don't panic, because this is no different than solving the last 2 equations. We're just going to use the order of operations backwards to start undoing things. And I can start that on either side. It doesn't really matter. But I prefer undoing subtraction first when compared to undoing addition. I like to undo subtraction first. That's just me. So on this side I have subtraction, and I undo it by adding that same number. Minus 7 plus 7 makes 0. Now, what do I do to the other side? Exactly the same thing. Where do I do it? Well, 7's a plain number. It's not an x term. So I have to keep like terms together. So I'm going to add 7 to the plain 9 because I can. I can't add 7 to 2x. So now, on the left side, the 7's cancel each other out. They make 0. We don't write them down. But we bring down the 4x because we haven't dealt with it yet. We put an equal sign on the wall. We bring down the 2x. We haven't done anything with that yet. And then we add the 9 and 7. 9 plus 7 is 16, and it's positive 16, so we write plus 16. Alright, now, looking at this busier side of the equation, it says to undo anything added or subtracted. Can I subtract 16 from both sides? Let's think about that for a second. If I subtract 16 here and then try to go over here and subtract 16, I can't. I can't take 16 away from 4x. They're not like terms. So let's look at the 2x instead. What if we subtract 2x? These two things are being added. This one's positive. So if I go minus 2x, it'll be gone. So what I do to one side, I do to the other side. Make sure you put that minus sign in front. Alright, on the left-hand side, 4x minus 2x is 2x. On this side, I've gotten rid of 2x by subtracting it, taking it away. I have 0. I'm too lazy to write it down, but I bring down the 16. Almost done. 2 times some mystery number gives us 16. Now, most of us can guess that that mystery number is 8. How do we know that? Because we're undoing 2 times x by dividing both sides by that 2. And that's exactly what I do in my head to get 16 divided by 2 equals 8. And 2 divided by 2 is 1, plain old 1x alone. The answer to this equation, the solution is 8. Why? Well, check it out with me mentally. 4 times 8, put the 8 in for x. 4 times 8, that's 32 minus 7. 32 minus 7 equals 25. Now I have an x on the other side also. If I put my 8 in there, I get 2 times 8 plus 9. That's 16 plus 9. Hold on, that's 25 also. When I check 8 in both sides of my equation, I get equal answers on both sides. I get the one number that makes this equation a true statement. Alright, tune back into the next video and we'll do the second problem on your notes page.